am preparing to make the reagents for the phosphorus test. First, we're going to make up a PAT solution, and PAT stands for potassium antimony tartrate, sesquiterhydrate. So when you make this, make sure you are using the right reagent. I found many chemicals with a similar kind of name. So that we make 500 ml in DI water, and we are going to refrigerate it in a glass stopper bottle. Next, I'm going to make ammonium molybdate. We measure that out. And we're going to make 500 ml, and we're also going to refrigerate it in a glass stoppered bottle. Next, I'm going to make ascorbic acid solution. And I'm going to make just a little bit of that, and I'm going to also store that refrigerated, but make sure it is used within 5 days. Strong acid solution is the concentrated sulfuric acid, and there's a little bit of nitric in it, and I have some here already made. And then we need a phosphorus stock solution, so this is going to be a double dilution. We're going to measure out potassium phosphate monobasic, and then we're going to measure out a certain amount in 500 ml, and then we're going to take 10 ml of that and dilute it to 1000 ml. So we should have about 1 ppm when we're done, and then I'm going to store it in the refrigerator. I am preparing to do total phosphorus using the digestion technique. I have made up a phosphorus standard. That's 1 ppm, and that is made out of the potassium dihydrogen phosphate, and I diluted it in another dilution. And then I am going to make standards using this solution that I made. We are going to make a control sample using this Hock reagent, which is about 1000, and we're going to make a 1 to 1000 dilution. And then we have our test sample, which is the Fox River water. So I have turned on my hot plate, and my spec is going, and I have my flask ready. So I am going to make up my standards. This one is a blank. There's no phosphate standard in there. And then I'm going to make my 0.02 milligrams per liter. I'm going to add 1 ml. To this flask. And then the next one, I'm going to make the 0.1 standard. I need 5 ml. I'm going to add that. Then to the 0.2, I need 10 ml. And adjust my pipette here. Add 10 ml. Then for the 0.5, I'm going to add 25 ml using this pipette. And then for the 1 standard, I'm just going to pour off 50 ml of this into here. Then to make our control sample, we are using this phosphorus standard, 1000 ppm. So we're going to put 0.5 ml of this into the 1000 milliliter volumetric flask, and it should give me a value right in the middle of all of these standards.
No, this is manganese, sorry.
And then I will
So the
take
manganese
everything here and fill it up to the 50 mil mark.
should be due next.
So everything is at 50 mils.
This is an
I'm going to
interesting
take
site.
each one and pour it into a 125 milliliter flask. Okay, everything is
Hang
poured
in there.
off. Then to each flask
through
you
this. I
add
know
1
it's
mil
not
of
ideal.
strong acid reagent using a glass pipette, which I have there, and I will pour some off into here and do that. Strong acid solution
Always
is
set. We're
mostly
ready set.
sulfuric acid and could have a little bit of nitric in there.
So let me finish with.
And then to all flasks we add 0.4 grams
with
of
the
ammonium
landfill design and
persulfate with the
operation.
ceramic
It won't take too
spoon.
long, maybe we'll take a
right
little
here.
break and then we'll jump into the recycling. Start
So,
seeing them at
adding the
produced.
ammonium persulfate.
So this is the.
Each sample we
acid
have.
phase. Fires,
So the next thing is to swirl
it can
and put in the hot plates
be a
to boil
danger.
down. So,
Confined spaces, any kind of
swirl.
holes.
And then I'll get them on the hot plate.
So that's the gas man.
Okay, they're on the hot plate. And we want to boil them down to about 10 mils. At this time we can make our combined reagent. I will go do that. So next we are making the combined reagent. We're going to add 10 mils of the PAT solution, and I already did that. 30 mils of the ammonium valproate solution, 60 mils of the ascorbic acid, and 100 mils of the sulfuric acid. So I already added the PAT. I'm just going to keep adding and adding. And then I will slowly add the sulfuric acid.
It's not unusual, I mean, a lot of taking through clean, and then after you clean them.
Make sure it's not getting too warm here.
Like little robotic things.
Feeling pretty good.
Wheels, I've seen, they probably come in all shapes and sizes, and then basically. What they're called?
Feels pretty good.
Okay.
Alright. And we'll be ready when the samples have boiled down. So while we are waiting, we're going to make sure our spectrophotometer is working properly by verifying the photometric accuracy using these different standards. So right now it's set to 510 and it's set on absorbance, but we have to change it to 590 and change it to transmittance. So we're going to change our mode, and we're on transmittance. I'm going to set our wavelength to 590, enter. So I have changed it to transmittance, set to 590. Right now, nothing in there. I'm going to measure a blank. Alright, I'm going to take out one of these standards. This one should be about 9.2. Let's put it in there. Should be about, there we go, 9.1. Very good. Let's take this one out. Let's take a 50% transmittance. And 50.4. Take a look at our range. 50 should be between 47.5 and 52.5. So we are good to go. We are going to use rectangular cuvettes for phosphorus. So I will remove this and put this center on. Alright, we are ready to go when we can. So Most of our samples have concentrated down to about 10 mils. And one more to go. And then we will cool. Take the squirt bottle and squirt on the inside and swirl it to get the crud off of the glass flask. Like that. And do that with each of them. Next step is to add 1 drop of Phenolphthalein Indicator to each of the flasks. After that, drop by drop, we're going to add 5N sodium hydroxide to each of them until each of these samples stay pink. After that, we're going to go backwards and add 5N of the sulfuric acid to turn the samples clear again. So I will do that. I'll add the phenolphthalein. Next I'm going to add sodium hydroxide until it turns pink. Take a look. Oh, not quite there yet. Still not quite there. Alright, it is pink. Now I'm going to add 1 drop of sulfuric acid at a time until it goes colorless. Well, almost there. There you go. Now I'm going to do that to each of these other flasks here. Alright, the pHing is now complete. Next we want to make the samples 50 mils again. So I have the 50 mil volumetric flask there, and I'm going to measure them out and then fill to 50 mils with DI water. So now all of our standards and our test samples are at 50 mils again. I'm going to take each of them and pour them into their flask. They are poured off, and then to each of these flasks we are going to add 8 mils of the combined reagent. Then I'll mix them, and then we'll set the timer for 20 minutes for the color to develop. It has been 20 minutes, and now I'm going to do the readings. Our spectrophotometer is set to 880 and it's on absorbance. First thing we need to do is read the blank. We have a rectangular cuvette here. We're going to add some of the blank, dump it to clean, and then fill it and put it in our spec and hit measure blank. I cleaned and filled my cuvette with the blank sample. Put it in our spec. Of course, you're going to be wiping the edges to make sure that there's no fingerprints on there. There you go. Hit measure blank. That out. Dump it in our waste bottle. Next we're going to add a little bit of our 0.02, dump it and refill it, and then we'll start taking readings from there. I've taken all the readings for my phosphorus standards and test sample, and let's evaluate. The 0.02 gave a negative number. That happened on my orthophosphate too. This looks reasonable. Something got missed here. Here's my 0.5 1.228. Here is my control sample, which is supposed to be the same level, and that is a bit off from there. And our high level, the 1.0, is above assay range. So this one would have to be cut out of the equation and have a range of 0.002 to 0.5. And this is our river sample. So these look flipped here, or something here. Or a misread right here.